Okay, thank you very much, ladies and gentlemen. Thank you for the introduction. So, I'm Sven, and I'm a pharmacist. And I actually worked here in Bonn for many years at the Apotheke am Friedensplatz, at the Friedensplatz. And guess what was moving in when the pharmacy closed in 2019? Yes, exactly. The most obvious one, a shop for e-cigarettes. What irony. So we have to face the obvious elephant in the room. The bribe of police had also to do with it. I do drugs. And we have to be a bit more focused on that. I do medication. So we will now go on the journey on drug discovery, which is a journey to the medication of the future. To actually know where drug discovery comes in, we need to remind ourselves how the drug development pipeline works. We start at the very end. So, once a drug is approved, it's the post-clinical phase. Me as a pharmacist, but also medical doctors, monitor these drugs and report side effects and stuff like that. Before that, we have the clinical phase under human participation. And at this stage, it's very obvious I was supported externally by two very young future scientists. Before that, we have the clinical, preclinical phase under animal participation. And just before that, we have the drug discovery. Drug discovery is associated with an important term that's called screening. We know screenings in our everyday life. For example, Ordnungsamt, that's going through the pedestrian area and checking for people not wearing their face mask properly. So the scientific approach would be the discovery of Maskenverweigerer. Alternatively, also discovery of Falschparker or discovery by Rot über die Straße Geher. We have also technical applications that work like screenings. For example, this one. So the scientific approach would be discovery of Geschlechtspartner. Or also, if you want it special, you have special applications. This slam is also some kind of a screening for me. I have to screen for relevant information to get the 7 minutes slam done in 7 minutes, which is already an issue right now. When we talk about screenings, there are two experimental setups I need to introduce. First, in vitro assays. These are experiments that are made outside of complex organisms. So how do we do it? We have a compound library that consists of chemicals we think that could be the potential medication of the future. We expose them to a target protein we think or we know that is associated to a certain disease. But we do not use the target protein itself. We use single cells that express, so they produce that protein. And we need functional tracers that indicate that this protein is changing its activity once exposed to that chemical. We put that all onto a 96 well plate. This is a standardized system, and then into very expensive machines. This can be compared to a cassette that's put into a recorder, and then the recorder says, in the ideal case, yeah, congratulations, you got data, great job. Let someone call the Nobel Prize Committee. However, that is actually how the reality looks like. You got laughed at, and just joking, you got nothing. But every once in a while, you got success. This is a screening graphic showing the change of biological activity when the target protein is exposed to a fairly high concentration of the target compound. And here we find one special hit compound. The problem is with hit compounds, you need a lot of them to actually move something. So we have the hit-to-lead optimization. This is promised the only, let's say, more chemical slide. So you see this compound 8 times, and it's slightly variated at specific points. And so we create derivatives of this hit compound with the hope that we will get compounds with better activity against this protein. We do that by organic synthesis. So organic, everyone knows that, it's good, it's healthy. Synthesis is like that one. Did you know that every 20 seconds one of these things is sold? Anyway, so that is exactly what I do. So I mix my organic components in a pot, and then I get new compounds that form my little own compound library. And then these compounds are tested in the same logistics. And after a lot of more frustration, we get this. It's a concentration effect curve showing the change of biological effect over the concentration range from a little bit to way too much. And we can see we have a lead compound that is much better because the effect occurs much earlier than the hit compound. This can be put into the later stage of the preclinical evaluation. But I promised you actually space exploration. So where comes it in? Well, we have another experimental setup. It's called in silico assays. So we do that in computers. And particularly, I'm focusing pattern analysis. Every one of you knows pattern analysis from crosswords, and no one admits it, but most of you will do that. And those of you who do will instantly have recognized the secret political messages hidden here. And that's basically the fundament of my work. I developed with colleagues a methodology called computer-aided pattern analysis. What we did, we wanted to correlate biological activity of compounds with molecular structures. And after a statistical analysis, which actually always looks like that when I do that, we get something called a fingerprint. Fingerprints give you information which chemical composition needs to be there to have a certain biological response. And you can use these fingerprints to screen compound libraries, but not the analogous ones I was talking before. I'm talking about virtual compound libraries. These compounds do not exist. They just exist in the computer, but we know already how they look like. So we can search for compounds with the properties we want. And these virtual compound libraries are called chemical space. Now you'd ask, okay, you showed what a medicinal chemist is doing. What makes your work important? Well, I have omitted one critical step here, and that is actually target identification. Before you can treat something, you need to know what you treat. And you need to validate that protein when you have it associated with a certain disease. And that's where this methodology comes in. We are searching for multi-target agents. And to explain that concept a bit more, so we all know that very famous series. So most medicinal chemists search for selective agents. So we have one compound addressing one target. We actually are searching for promiscuous agents. So one compound addressing several targets, because this increases the chance that we can actually address yet undruggable targets. Not only exploring chemical space, but also target space itself to explore the target protein of the future. And that's it. Thank you very much for your attention.
Thank you, Sven, for the space exploration trip. And now it's deliberation time again. Was the slam you just saw understandable? Was it entertaining? Was it scientific? You all got 2 minutes in your little groups to do so. Folks, if you're still at a table with no booklet, there's still a group of 3 and a group of 4 waiting for you. They're very sad.